Hi everybody. In this section we're going to talk about something called correlation. And before we get to what that means, let me just mention that in the next couple of sections we're going to be focusing on quantitative bivariate data, in other words, numerical data. Now, just like in algebra, we will typically call the independent variable x and the dependent variable we'll call y. Remember, that terminology means we're saying that y somehow depends on x. Now, in statistics, we often call these the explanatory variable and the response variable. In other words, we want to see if a change in x explains a change in y. Or to put it another way, if a change in y is a response to a change in x. And let me back up and just let's elaborate a little bit more on this explains. When I say explains, we basically mean like causes. In this section, we're going to talk about using scatter diagrams to visualize this. First, we'll talk about types of correlation, and I'm going to illustrate these with some examples. So, example 1. Suppose each year you go to a birthday party for each of your cousins. You will also have a birthday party of your own that your cousins will attend. Then the number of cousin birthday parties you will attend will depend on the number of cousins you have. So, for example, if you have one cousin, you're going to go to one party for that cousin, plus you're going to have a party of your own. So that means a total of 2 of these cousin birthday parties you're going to be involved in. Or say you have, 6 cousins. Well, you're going to go to 6 birthday parties for the 6 cousins, plus 1 for yourself. That's a total of 7 parties. So in this example, the number of cousins is the independent or explanatory variable. The number of parties is the dependent or response variable. So the number of parties you go to depends on how many cousins you have. There's a clear mathematical relationship between these two things. And in this case, the relationship is simple enough that we can come up with the equation for it pretty easily. And it is that if y is the number of birthday parties, and I'm letting y be the dependent variable as usual, that's going to be equal to the number of cousins plus 1. Now, having a mathematical relationship between the two variables is what we mean by having a correlation. So, these variables are correlated. Notice these dots line up in a straight line. You could draw a nice straight line through them. So there's a mathematical relationship between the number of birthday parties and the number of cousins. When there's a mathematical relationship between two variables, we say they're correlated. And because these line up in a straight line, we call this a positive linear correlation. Let's see another example. A person tracking their macronutrients finds that for every extra 10 grams of protein they consume, they just naturally seem to consume 20 fewer grams of carbohydrate. So they tracked their intake of both of those things, and they saw that, for example, if they only consumed 50 grams of protein one day, they tended to consume a lot of carbs. They consumed 190 grams of carbs. Whereas, for example, if they bumped up their protein intake to 90 grams, it turned out their carb intake went down to 120 grams. And overall, they saw, again, that there was a decrease of 20 grams of carbohydrate for every 10 grams of protein consumed. So in this example, the grams of protein is the independent or explanatory variable. Whereas the grams of carbohydrate, I'm just going to call it carbs, is the dependent or response variable. And it might occur to you to wonder, well, how do you decide which is the dependent and independent variable? In this case, the person doing the tracking was the one that decided that. And what was probably going on was they made an effort to eat more protein, and they didn't try to control for their carbs, and they found that the carbs just naturally responded. That's kind of like in section 5.1 when we talked about treatment and responding to treatment. So this person gave themselves the treatment of eating more protein, and they found that affected the amount of carbs they ate. Once again, these dots line up in a nice straight line. We could draw a line through them. So again, there's a mathematical relationship between them. So again, we're going to say that there's a correlation, and again, it's linear, but this time we're going to call it a negative linear correlation. Now, why are we calling this one negative and the other one positive? Well, you might remember from algebra that if a line goes uphill, and I mean from left to right when I say that, its slope is positive. That was that m thing that we always called the slope in algebra. So if the slope's positive, your line's going uphill if you go along it from left to right. Similarly, if a line goes downhill, and again, I mean from left to right, that's the direction we always look at graphs in math, then its slope is negative. And that's all these words positive and negative mean in this context. Saying something has a positive linear correlation doesn't mean it's got a better correlation than something that has a negative linear correlation. It just means that one's going uphill whereas the other's going downhill.